This is ISE Labs, and we have audio now. And you love it. So, like I was saying, what we're going to be doing is that we're doing research throughout the year and then presenting some of that research over live streams. And then today, we actually have Shaun Mirani, who's been doing some research on a project, and he actually is going to walk us through on getting a root shell on this device, and that's going to be pretty exciting.
Yep, I'm Shaun Mirani. I am a junior security analyst here at ISE, as well as a research assistant at ISE Labs. I'm also a student at the University of Maryland, where I study computer science. And today I'm going to be walking you through a vulnerability that we found and disclosed in the ISE Store AS602T NAS device. It's going to give us a root shell. So here we go. Let's get started. So right now I'm at the web interface for the NAS device. I'm going to go ahead and log in with our account. It's called super user. So as you can see, it's a pretty straightforward NAS interface. You've got some locations for settings, viewing information about the system. You've got a basic file explorer, list of devices. But for this stream today, we're going to be focusing on the services section of the NAS. So I'm going to click in there. So the ISE Store has support for a bunch of different services, ranging from Windows and Mac compatibility to NFS. You can also access your files on the NAS from an FTP server. It's got support for WebDAV. I believe this is for hosting your own website on the NAS. There is also a database, SSH access, which is going to be important later on. I will get to that. rsync for synchronizing files between your local computer and the NAS. TFTP, SFTP, and SNMP. So when you're looking at a list of services, it's often difficult to know where you want to start. And a good place that we decided would be ideal for starting is to check where and which endpoints actually enforce authentication. Because if there's an endpoint that doesn't have proper authentication checks, and there's a vulnerability in that endpoint, it's going to be a lot more severe than if that vulnerability were in an endpoint that did have authentication checks. So for example, if you're able to get a shell without even having to log in, that is far, far worse than the fact that you have to already be an attacker on the local network and you already have to know the password for the NAS device in order to get the shell. That's almost intended behavior. So what we're going to look for today is endpoints that don't enforce authentication. And to help me do that, I am using this tool called Burp Suite. It lets me intercept my HTTP traffic and modify it. It's basically just acting as a proxy between my web browser and the NAS. So over here in this window is a list of all the requests that my browser is making to the NAS. The most recent one was to portals, APIs, events.cgi. But since we're interested in the services section, we need to find all the endpoints that handle these various services. And let's look at one of those. SFTP. Let's send that to the repeater and see if we can change the request to get it to do different behavior. So normally when you're logged into a web application, the way the application knows that you're logged in and what authorization level you have is via the cookie. So if we were to get rid of the cookie and we could still access this endpoint, that should be bad because it means we don't have authentication and we're still able to access the service. So let's go ahead and delete that cookie. Okay, so the server responded affirmatively with this JSON data. There's some interesting stuff here. See file paths, port number, usernames and such. Yeah, more directory names. So this would be dangerous information if it could be accessed without authentication. But the cookie really isn't showing the entire story because I'm going to undo my deletion of that cookie, and it's back here, and it sends it again. So you see this as SID cookie name. This value is also present in a URL parameter up here. So there's also authentication data in the URL itself. So if we really want to test auth on this endpoint, we have to remove this one as well. So I'm going to go ahead and do that. Delete the cookie, which we know it should accept because we just tried that. And delete the SID as well, the session ID, as I presume it stands for. I'm going to reissue that request. And it says success false, error code 5000. Now, I don't really know what 5000 means. It's all contextual, but my educated guess would be that it means you don't have authentication or authorization for this endpoint. That would be the most reasonable interpretation of that. So this means that the endpoint sftp.cgi requires authentication in order to view that information. So that's only one of the services. Just because one endpoint has the correct authorization checks and everything doesn't mean they all enforce the same level of security. What I want to do is test each individual endpoint, giving it the proper parameters that it needs, but changing the SID or removing the SID such that I can access that service without authentication. Now, I could go ahead and manually look for each service. In here, you can see TFTP server. So if I send that to the repeater and, for example, get rid of the cookie and get rid of the SID, again, you get the error code 5000. But I really don't want to manually go in and do this authorization check for each and every single endpoint. I want some way to automate, in an automated fashion, check the authentication protections for each endpoint. So one way to do that is by using the Burp target tab to enumerate all of the endpoints under services. So if we go back to the browser, you can see that, actually, if you go back to Burp Suite, the endpoint that handles these various services is located under /portal/API/services. So if we go to the target and we list everything under portal, APIs, services, then we have a list of all the URLs that correspond to these service endpoints. And what we can do is we can copy all of them, copy URLs in this branch. And what I'm going to do now is put those into a text file. We'll call that services.txt. We'll just paste that in. You'll notice that there are some duplicate entries. Some of them have query parameters and some of them don't. That's where the duplicates come from. I'm going to get rid of that with some scripting. So what I'm going to do is read from the file. So while read line, do, and we want to grep the line for the SID parameter, because if it has a parameter in it, it's going to have SID, because all of these are supposed to be authenticated requests, theoretically. So grep SID equals, and we're going to read from services.txt, and we're going to write that to services2.txt. And this should work. Yep, so now we have a list of all the service endpoints that only have parameters. We don't want things without parameters, because then you're not getting all of the, you're not supplying the server with all of the parameters that it needs in order to fulfill the request. And so you're getting into different territory there. So now that I have this list, I'm going to process them and change the SID. I'm going to either remove the SID or swap it out with something that's not a valid SID, and I'm going to pass that to curl. Now, curl is a basic command line utility for making HTTP requests. So I don't need the cookie, right? And that's great, because with curl, I don't necessarily have this entire cookie information that I had before, right here. So that's good. I don't need that. I am going to, however, change the SID to correspond to an invalid token. So while read line do, I'm going to echo the line just so I know which one corresponds to which curl request. And then I'm going to echo that into sed, which is a stream editor for modifying text input and just replacing it or altering it in some fashion to get what we need. So I'm going to echo the line into sed. And to do sed, we use this string replace format. So s/sid equals. Now I want to match. It looks like these are all. Looks like these are alphanumeric with dashes. So I'm going to use a regular expression to match that. To do that, we need to pass the -r flag to sed. So we can do something like this to match sid equals and then a word character or a hyphen. And then we will replace that with some garbage value that's not a real sid, like fake sid. And we have the G because we want to replace all of them globally, not just the first one. Let's just make sure this works before we do anything else with curl. Forgot I have to read from the file. Okay, so my replacement was off. I don't want to just replace the actual sid value. I want to replace the text sid equals as well. So sid equals fake sid. Oh, no, there is still some authentication data in there. Why don't I just remove this echo, get rid of that. Okay, not sure where that token is coming from. Is there a different flag that I should be using? Okay, well, I guess that doesn't really matter because whatever this is, it's not a valid SID because it has additional data in front of it. So we're just going to go ahead and write that to another file. Read from the file. Okay, so now that that is done, now we have fake SIDs filled in for where the real authentication data should be. Now we can read from this file and curl every single URL and see which ones respond with the response that we're expecting, even with an invalid SID provided. So once again, we're going to read line by line, and we're going to curl the line. While read line, do curl line, and done. And let's echo the line before each curl command so that we know which one it corresponds to. Okay, so we just made a series of HTTP requests to these modified URLs with invalid authentication data in them. And as we might expect, a lot of them responded with success false, error code 5000, for example. One of them did not. One of them actually gave us some pretty sensitive information, a password in there, for example, an IP address, some username information. So this is the SNMP endpoint. So let's go back to Burp Suite and make sure that's actually for real, that it's not just something I forgot to do in the terminal. Let's find the SNMP endpoint in here. And we're going to send it to the repeater once we find it. There we go. SNMP.cgi is the name of the file. The normal request gets the same information that we saw in curl. Let's remove the cookie. Okay, that works. And let's change the SID. Instead of just swapping it out for something else this time, let's completely remove it. Cool, so no more SID. This is in fact an unauthenticated request to the SNMP API, and it's giving us sensitive information back, which is a huge red flag. When you're assessing these kinds of systems, you want to pay attention to the endpoints that behave like this, because it means something is up. Now there's also another _DC parameter in there, but I'm pretty sure that doesn't matter, because this looks like a timestamp. And this request happened a while ago, so I'm going to see what happens if I remove this. Okay, it didn't make a difference. So my guess is that that parameter was just there to prevent caching of this response, and it doesn't actually mean anything in terms of how the application handles a request. So now that we have this request, let's see what else we can do with it. Going back to the web browser, initially we were able to get some JSON data from the SNMP CGI endpoint. What if we were to make a different request, like change some settings here? Community was Bork, we're going to make it Bork1. And let's just make the username Bork1 just to see. I'm going to hit apply. Go back to the Burp Suite proxy. Sort by chronological order and find where that SNMP data was. Okay, so this is the request we just made to apply those changes. User is Bork1, given by the row user parameter, and the row community, or the community, is Bork1 as well. So that's the one we just made. Let's go ahead and see if this state changing request also doesn't need authentication, because while I have a suspicion that it doesn't need any auth data like cookies or the SID parameter, that's not a given, and you should always check, because these go down different code paths in the application, whether it's merely retrieving some information or updating it. So I'm going to delete the SID and delete the cookie. And just get rid of the _DC parameter, just for good measure. And if all goes well, for our vantage point, we should get a successful response. Well, so yeah, that is a successful response. That's true. So that means we can now update information on the device, wherever this information is being stored, wherever it's being handled. That endpoint accepts requests made without authentication. So that's good for us, because it means we're not going to focus on the SNMP.cgi endpoint for exploring further attack surface and more vulnerabilities. So on its own, this doesn't tell us a lot about what's happening on the back end. Like, we can see that some settings are being changed and some parameters are being given, but we don't really know what the NAS is doing with our information. Depending on what it's doing, it could range from between anything like SQL injection to command injection, or it could be something trivial, well, not entirely trivial, but less severe than those, like cross-site scripting. So we are actually going to use the access that I mentioned earlier via SSH to log on to the server of the NAS and look at where this SNMP.cgi code actually lives. So to do that, we know that SSH is enabled on port 22, and we have the IP address of this NAS, so we're going to SSH into it using just the super user account that the web application uses as well. The IP is 119. Okay, so now that we're in the device, where do we start? Where would this snmp.cgi file be located? Now, I don't know off the top of my head, but a good way to do that is by using the find command. We can, if the endpoint itself is named snmp.cgi, there's a good chance, it's not a guarantee, but there's a high probability that there's also a file in the system called snmp.cgi, or at least a file that ends in .cgi that contains a handler for SNMP. So what I'm going to do is I'm going to look for everything that ends in .cgi, and we're going to go from there. This is the find command. All it's doing is it's going to match the pattern star.cgi. So find everything on this file system that ends in .cgi. Okay, that's great. You know what, I'm going to go ahead and rerun this command as root just to make sure we're not missing anything. And because I don't want to see all of this permission denied output that's kind of obscuring what's really going on. Okay, so yeah, there is a lot of stuff that ends in .cgi, and I can kind of make sense of it. This looks like the format of the URL we just saw in Burp Suite. Portal, APIs, services. This one's settings, but you get the picture. Okay, I see services. So Wi-Fi. Okay, mac.cgi, sftp.cgi, http.cgi, and snmp.cgi is right up here. So I'm willing to bet that's the actual file that contains the code that's handling this request. So if we go to that directory, we can see that it has all the services CGIs in here. So because this right now I'm SSH'd onto the NAS device and I don't have a lot of my tooling on here, I don't have the commands that I use for analysis, I want to copy this file off the device onto my local systems to make it easier for analysis. So to do that, we can use the scp command, secure copy. It'll just copy the file over the existing SSH connection to our local file system. Excuse me, not the existing SSH connection, but the existing SSH service. So the format of this is scp, the username, so superuser at the IP address, colon, and then the path to the file, the full path to the file that we want, without this dot, and then the directory you want to copy it to. So we're going to copy it here to this local directory. And we have to enter a password again. That's great. Looks like we have the snmp.cgi file. What kind of file might this be? I have a couple of guesses, and they're all perfectly valid. Number one is it's a script file, like a Python or a Perl script. And that is pretty common in these kinds of IoT devices to have scripts that are named .cgi or something similar, and they just act as handlers for the web application. My second guess is that it's a native binary for the operating system, which is Linux. So it could be either of those, but we can use the file command to find out. snmp.cgi elf 64-bit LSB executable x86-64. So it's a 64-bit native binary, which is, it makes our analysis a little bit more difficult because we can't just look through the source code if it were Python or Perl or something like that. But I mean, it's also possible to reverse engineer these files pretty easily, so it's not that much of an impediment to our reverse engineering process. A first command that I like to run when I first get an unknown binary is the strings command. This will basically give us a list of all the ASCII strings that are present that have been compiled into the executable, and that is very helpful because oftentimes it reveals information that could be of use for an attacker, like URLs, host names, file system paths, passwords, things like that. Even function calls that could be present in the application. So if we run strings on snmp.cgi, we can see there definitely is some English text in here. See error codes. These definitely look a lot like the parameters that we gave it, such as enable SNMP, row user, password, things like that. Like I mentioned earlier, there's function calls here, error messages, some JSON, formatted strings that look like they take printf style format specifiers. What's interesting is there's this file path here. User built-in etc snmp ISE Store snmp.conf. Sounds like a configuration file to me. Also, you have what looks like a path to an snmpd file in sbin, which tells me that it's probably the snmpd agent that's running on this server. So this is useful information, but let's go ahead and see if we can disassemble this binary to get a little bit more information about what it's doing behind the scenes when we actually make a request. To do that, we're going to use IDA Pro, which is basically, it's the interactive disassembler, and it's going to allow us to take the file and print it out or view it as assembly code in a linear fashion, and we'll be able to see all the function calls and places it jumps, and it'll really help us to analyze what it's doing under the hood. So once I log in, we'll be able to open up IDA Pro. And while it opens, let me just make sure that file's in the right location. Okay, it is. So we are going to disassemble this file, all files, snmp.cgi. Cool, so it detects it as a 64-bit executable, ELF. And we do have a lot of information here. So let's see, on the left-hand side, we have a window that just lists all the function names. Looks like, make some calls to fwrite, strcomp. There's something called getConf file in 32 value. Execute command, now that's always interesting to see. But I'm going to go ahead and sort these functions, and what I want to do is start at the main function, because that's probably the entry point for the application when it receives a request. So if I go into main, down at the bottom, so let's dive into this code right here. Okay, so I see some strings that might be of interest to us. There's this act string right here, and I recognize that because I've seen that in Burp Suite, act. So that's probably the name of one of the URL parameters that gets passed to snmp.cgi when we make the request. So it's loading this string value act, and it looks like it makes a call to get param, so probably getting the value of act. And then if that's successful, it's going to go here to this branch. And it compares it to the string get. So if act is set to get, then it's going to go down one of these branches. So it'll go down here. And then that looks very much like it's going to check the value of tab in the URL. This tab is right here. Once again, it calls get param, and if successful, it will check what tab is. In this case, it's checking get with an uppercase G. In our case for SNMP, we have set, uppercase S. So that's quite different. Why don't we see if we can go through this code and find where and sort of follow the path the application would take if we made this request. So act is set to set with lowercase s, and tab is set to set with an uppercase s. Here's the first set, and tab, and uppercase set, so it's going to go down here. And it looks like once it determines that both of those set parameters are included in the request, it appears like it's going to call function 401 FB0. So what if we go there? Okay. So it's going to go down here. There's a string enable SNMP that gets loaded into a register. And a bunch of move instructions setting locations to 0, followed by a call to get integer param. Now, I believe it would be my guess that what it's doing is simply getting the value of enable SNMP, this string, as an integer. And that makes sense because in the request it's provided as the value 1. So it totally makes sense that you would give it an integer. So let's follow that branch. Okay, that's not where we want to go. So then it gets enable SNMP v3. I should probably talk a little bit about the differences between the various SNMP versions. So in terms of security, SNMP is, well, it leaves a lot to be desired, to say the least, because SNMP v1 is unencrypted. It operates over UDP port 161 typically, and it sends everything in the clear, including your passwords, including the community string and the information that you're querying. So when you want to use SNMP to query information or list information on a device in the form of variables, that's all sent over the wire in the clear. An attacker who's eavesdropping on the network can see all of that and modify it as well. So that's bad. SNMP v2 adds optional encryption to this scheme, but SNMP v3 bakes it in by default. So while the implementation that comes with SNMP is not particularly strong, SNMP v3 is in fact encrypted, whereas SNMP v1 and 2 are often not. So this is another parameter it's processing. Yet another one, now it's getting to row community. Let me zoom in there. It's processing the row community parameter. Right now, it's still just getting all of the parameters that we give it and storing them in variables. That's all it's doing. And if we keep going down, we can pretty much see the end where it has received all of the parameters. And so let's see. The last one was password. So it's going to go oh, I see, we want it to not be 0. So if it's not 0, it's going to jump here. And then jump here. So then once it gets to this point, it's going to, there's that file path again that we saw in strings, in the strings output. It looks like it's going to load the string enable SNMP and the string SNMP in all caps, and using that data, it's going to read from this file by using getConf file integer value and receive a value of whether SNMP is enabled or not. And if it's not 0, it's going to go it's kind of hard to make sense of when you have so many different locations it's jumping around, but if it's not 0, it's going to go there. Okay, that's an error, so we don't want to go there. But otherwise, it's going to go here. And it looks like once it gets here, it's going to start setting some values because you have a call to set pair integer value. So I imagine that is what it's going to do once it knows that it has all the required parameters. Set pair string value as well. And then finally, it looks like we have a call to update conf file section, which takes this file again, this file name, and it probably writes the data that we provided to it in some fashion. It's over here. So it looks like given some certain combination of values, it's going to kill the SNMP process and restart it maybe? Yeah, that looks like what's going on. But since again, we're following the branches it would take if we sent this request, we need to pinpoint exactly where it handles all the variables that it receives from the parameters. So at this level, we have all the errors that get raised if they're missing or invalid data. The command to run SNMPD. This is the output, the response that we get once we issue a successful request. So you can see they have success true in one branch and success false in the other. That's a little bit ahead of where I want to be. So I'm going to go up. And so this file path really keeps cropping up everywhere. And so that's of a lot of interest to me. So what I think I'm going to do is, using my SSH access, I'm going to go into the file system and look at that file, look at the contents of it, and look at the files nearby. See if any of the data we provided ends up there and in what format. So I'm going to minimize Pro, go back to my SSH access, cd user, built-in, SC, SNMP, and it looks like we have two files here. ISE Store snmp.conf and snmpd.conf. So the first one's what we saw a lot in the disassembly. That has whether or not to enable SNMP, something called a trap mask, which in SNMP is a trap is when an error is raised, typically due to authentication or security or some other failure, it's going to send some information with that error to a remote host. In this case, it's 192.168.1.1. So a trap is just something that gets raised in response to an exception. And a mask defines what kinds of exceptions get raised, what level. For example, do you want all of them or just want the most severe, or do you want nothing? So going back to the browser, we saw that the trap address we gave in here, 192.168.1.1, was given to this file. If we update this to a different trap address, so a different location where trap messages are going to be sent, we hit apply, I think it may update that file. Yep, looks like it has the value 1.2 instead now. So what can we do with this? I'm not sure yet, but let's take a look at the other file. This has a bunch of lines and a lot of the information we gave it. So row community, we saw that everywhere in both Burp Suite and the disassembly. Orc1 is the name of the community as well as the user that we added. Passwords is the literal string of the password that I provided. And again, Bork1 is the user. So to really understand what's going on here, it helps to know a little bit about the file format for SNMP. Now, SNMP is broadly used to list and query information about a system from a remote device. So suppose you want to monitor the temperature of your NAS, or how many users are connected to it, or what IP addresses are connected to it, things like that. You can monitor those. And so you need some of this information to be able to query that. So it helps to know where these different pieces of information fit into being able to query SNMP data. So one thing we can do is we can read the man page for SNMP, specifically the format of snmp.conf. See if there's anything malicious we could possibly do to exploit and take advantage of the fact that we're able to put certain values in that file. We just don't have context for what they do yet. snmp.conf Linux man page, that looks good. So if I zoom in and, so we saw row community a lot. Let's search that. So row community takes a community name. So specify an SNMP v1 or SNMP v2c community that would be allowed read only, get and get next, which we will get into, or read write, get next, and set access respectively. So the community is basically just an identifier for the sort of grouping of all the variables that you have in your SNMP storage. So if you don't have the community name, in other words, you cannot really query this information. So you can set it to anything. It's just an arbitrary string. All it does is allow you access to the information. Create user, we saw that option. Create user. So it looks like it takes a username. Yeah. A username, a hashing algorithm, some other information. In our case, we just have create user, the username, the hashing algorithm, in this case is MD5, and a password. So that's what that's doing. What I'm trying to do now is look for interesting SNMPD configuration options that could be used to, for example, run a command or read a file or write a file. If I can do any of those, that's a huge vulnerability, because remember, this endpoint is all unauthenticated. And if I can change the configuration file without authentication, and there are certain options for doing things like reading or writing files, then that means I have access to the device effectively without authentication. I'm just going to search for command. Process monitoring. Registers a command that can be run to fix errors with the given process name. Well, let's keep going. Maybe there's another. Exec and sh invoke the name program with arguments of args. By default, the exit status and first line of output from the command will be reported via the X table, discarding any additional output. So we can run a command and get the output, theoretically, if we use the exec or sh options. These are part of the arbitrary extension commands when you want to extend agent functionality, because SNMPD provides a lot of variables about the system, but suppose something you want isn't there. You can create your own bash script or something like that to report some information that you do want, and you can add an extend or exec or sh line in there to run that command and give you the information you want. So that's why this exists. Because it does seem like kind of a security hole that you can just run commands, but then again, this isn't really supposed to be run without authentication, and the protocol assumes that anyone who's able to edit the configuration file and insert an option to execute a command already has authentication to the device. So I suppose we can Google a little bit more information about these this family of commands or configuration options. So SNMP exec option, extending SNMPD using shell scripts. Oh, that's great. They have an example right here with a very simple snmpd.conf file and 2 lines: row community testing and extend test bin echo hello. So they retrieve the value using SNMP walk, which is a command line utility that simply walks the tree of SNMP variables on a device, getting them one after the other, so you can enumerate all of the variables that exist there. So it looks like they simply just add this to the configuration file. And once they do that, they can query the information using SNMP walk, and it gives them the output hello, which they echoed using bin echo. All right. Well, going back here, it doesn't look like we control any whole lines in the configuration file. We control parts of the lines, such as bork1 password, but we don't control the start of the line, which is kind of necessary in order to do this, because we need to have the line starting with the text extend or exec or sh. So here's where we have to play around with the request a little bit. We know we control, for example, the row community parameter, and that goes right here. We control row user as well. So row user, bork1. If we want to get this data on the next line, one simple thing to try is just to add a new line in here. Now the URL encoded form of a new line is %0a. So if we add %0a in front of bork1, we might expect to see bork1 on its own line instead of instead of following the text row user. So let's issue this request with a new line in front of work1. Success true. And let's catch the file again. And yep, we got work1 on its own line. So I mean, that's that problem solved. Now we can just put extend and then a name of, I guess, that option line, and then the program we want to run with its arguments. So just to copy this example for testing purposes, we can do %0a because it's a new line, extend test bin echo hello. Now, I'm not sure if the bin echo is necessary, but we'll see. Maybe we can just do echo. Okay, we got a successful response. Let's see what happened in the file. But that looks awfully like what we need for this option to work. Although we might want to add a user there because it looks like this row user is without a line and that might make the configuration invalid. So let's just put %0a, before the %0a, let's put work1 again. Make sure we have a valid row user in there and that so that SNMPD doesn't just fail upon reading this file. Good, so we've got our user in there and we've got an extend line in there. Now, how do we actually run this command? Because we can't see any output. I mean, we have no idea where SNMPD is echoing this. We'd have to use SNMP walk like they do to retrieve the value. So we can copy this, and hopefully it'll give us similar output, if not the same, where we'll be able to see like hello being issued as a string. Zoom in here. And we need to change a couple of stuff because the C flag is for the community name, and in this case, your community name is work1, not testing. So we can change that. Also, I'm going to change the version of SNMP to v1, just for simplicity's sake, even though it's unencrypted and everything. And the IP address, it's not 127.0.0.1, it's 119. Hopefully we'll be able to get some output with this. Okay, unknown object identifier, sub ID not found, NS extend output 1. What did we do differently? Okay, let's back up. Let's try to do this without any additional information after the IP address. Stop that early. See how long it goes. Okay, not too long. That's a lot of information. So all of these numbers interspersed with dots that you see here are called OIDs, or object identifiers. They're used to uniquely identify the names of variables on the system. So for example, if I scroll up a little bit, or just to the top, we can look at the top of the output. So this OID, ISO.3.6.1.2.1.1.1.0, corresponds to this string, which apparently is the operating system information, the model of the NAS, and kernel version, potentially, followed by the date and time, as well as the architecture of the CPU. So each of those OIDs corresponds to a different variable, and the extend lines or the exec lines in SNMPD are no different. They also get their own OID. So the problem is we have to find that OID, the correct one, in order to run the command that we injected, echo hello, and see the output. Obviously, NS extend output 1 is not going to work, so we have to try something else. Can we try SNMP translate? Unknown object identifier. So that's no good. Well, worst comes to worst, all of these, every single OID is pretty much standardized in SNMP. So if we look for the specific OID that corresponds to the extend option, we can just use that one. And it's not going to be in text format, it's going to be in the numbers format, but that's okay because, like I said, it's standardized. So SNMP extend OID, we can just look that up. And this looks pretty promising. Which OID to check for extend output in SNMPD? It looks like they use using SNMP walk, the community, the host, and it looks like they use this OID to pull. Oh, and it they actually have a similar script, like just echoes some information then returns. So if we copy this OID, maybe that'll give us some more insight into what's going on in terms of being able to execute this command. So we want SNMP walk and we want to connect to the same host, but we want to use this OID instead. Okay, so that is different, what they have. But that's to be expected because they have a different command. So okay, I see what's going on. So it looks like when we injected the command, there was some extra information in there, like MD5 password, that was supposed to be headed after the username in the create user option or the row user option, but didn't get added. So what we can do there is we can add the command injection or the configuration option injection into the row community line instead, since that is what we have control over. So row user is back to bork1, but row community can be bork1%0a, and then extend test bin echo hello. Okay. Okay, that looks much better. Although it does have our extend option twice, that's fine. We should be able to get it even if it's twice. So let's run this SNMP walk command again, and that's good. We can see the string hello that we expected. Now, just to make sure that this isn't just some kind of one-off thing or some fluke, let's change the command we're running to, instead of echoing hello, let's run something like ls or ls-la. See more verbose output. And what happened here? I forgot the ampersand. Good, success. Okay, the command is all in there in place of bin echo hello, and we're going to run this again. It looks like the output this time has changed. Instead, it's ls no such file or directory. So that is a sign that we do in fact need the bin in front of the command. So in other words, we have to give the full path to the system command, otherwise we can't run it. Probably because SNMP doesn't have our path information, like it doesn't know to search in bin automatically. So that's fine, we can just provide the full path to ls, bin ls. And I'm just gonna trust that it added everything to the configuration file as I expect, and run this SNMP walk command again. Well, that's it's really good because this is exactly the ls command output, and it shows up in the SNMP walk output for this OID that we're querying. So that's good. We can also run some more interesting commands. I mean, now that we have the ability to run commands on the device, like why don't we try to receive a shell or something? So we could do a reverse shell. That's one option. But this NAS also happens to ship with a service called telnet. The command to run the service is telnetd, and what it does is it essentially allows us to log into the device. It's unencrypted. It's just a lighter weight version of SSH, and we'll be able to get a shell as whatever user the web application is running as, and basically have full access to the device. So let's look at telnet and the proper form of the command. So it looks like the -L flag is what you want to execute as your shell once someone connects to it. And the only other information I would add in there is the port to listen on. So we can do that. We're probably going to want a command like telnetd -l/bin/sh, the canonical shell, and a port number. How about we use like 1234 for this example. Copy that and put that as the string to inject in our configuration file and see if we can actually get a shell on this. Telnet al bin sh. Success true. Okay. Let's query the extend variable again. And there's nothing there this time. What is going on? Oh, that's an obvious mistake. I accidentally got rid of the extend option name, so this isn't even a valid line, and SNMP is not responding to us at all with this. So that's a simple fix. Just got to add extend there and whatever we're calling in this case test. Good, so it's in the right format this time. Let's see what SNMP wants to say. Telnet, no such file or direct. Okay, so once again, we forgot the full path to the binary. That's fine. We can just do where is to find where telnet is, or which telnet d. So user sbin telnet d. And we'll just swap that out for the full path. And hopefully we get the shell that we were expecting. Okay, so that's right. So telnet it's not supposed to have any output when you run the command, but if we connect to it, using netcat for example, port was 1234. Looks like we have a shell. Zoom in a little bit there. And we are located inside / the root of the file system, and we are root. So that's good. So this means that the web application that calls SNMPD is running as root, and therefore SNMPD is running as root, and therefore when it runs telnetd, that also spawns as root. So we now have a root shell, even though we previously had no credentials, like we did not even have the password for the super user account. This is entirely unauthenticated. So this is a really neat vulnerability. So we can now try to like package it up in a convenient script that does this like automatically for us instead of having to mess around with Burp Suite and run SNMP walk and fuddle with OIDs. We can now just run our proof of concept script and get a shell. So let's start working on that. We're going to write it in bash because I think that's simplest for this case. And I'll show you why in just a sec. So Burp Suite has a really nice feature for copying requests in curl format. So it'll automatically take this request and convert it to a curl command that we can just run in the terminal, and it should give us the same response that the server gave us here. So it's just converting this to curl. Also, one thing I want to do before I do that is clean up this request, get rid of any unnecessary information, because the curl command tends to be kind of long, it doesn't look nice, so I want to clean that up before we actually convert it. So let's start getting rid of any extra information we don't need in here. So first of all, we can get rid of the SID parameter because there's nothing in it anyway. It's unauthenticated. We do need act and we do need tab because as we saw in the disassembly, it does look for those specifically before going down the path where it modifies the configuration file. In HTTP 1.1, the host header is necessary, so we have to keep that. Content length, that's necessary for our post data. Origin, I think we can do without that, so I'm going to get rid of that. X requested with, that's gone. User agent, gone. Content type, let's keep that. That's probably necessary for parsing the parameters that are as part of the post request, so we need to have that. On this side, connection close can go. Accept language, accept encoding, refer, accept, everything else is gone. So let's reissue this command and make sure that it works. And it does indeed work. So that's good. Now we can just simply copy this as a curl command using Burp's built-in copies curl command feature. So it's kind of messy, but essentially all this is doing is sending our request to inject a extend configuration option into the snmpd.conf file, so that once we query it using SNMP walk, we can run telnetd and then connect to it using netcat. The second command we need to run is SNMP walk, and that's simple enough. That's just this. So we have SNMP walk and the curl command in there. Now all that's missing is the telnet part. So connect to port 1234 on the NAS device, which corresponds to the telnet service that we have listening. And we can save this file. And back in the NAS, let's kill telnetd so that it doesn't like interfere with whatever, doesn't interfere with the exploit we're running. So we can do kill 3965. Sudo kill 3965. Okay, I guess it doesn't like that. It's not bash, right? It's ash, so it probably doesn't have support for all the fancy stuff like that, like running the last command you have using bang bang. So now telnet is gone. Just to show you, we cannot connect to port 1234 on this. Connection refused. With this exploit script, however, we should be able to. So let's go ahead and run it. Just making it executable now with chmod and running it. Neat, so it did get the shell. Print working directory, who am I, root. Yeah, so that's pretty much all there is to exploiting this vulnerability. You inject the configuration option with your malicious extend command, walk the SNMP variables using SNMP walk to activate the command, and then you telnet into it using any program like telnet or netcat, and then have a root shell. So I did want to talk about a little bit about why attackers in the real world would find this vulnerability particularly valuable. It's because when malicious actors are looking to create botnets using the Internet of Things or IoT, they generally want vulnerabilities that are easy to exploit and that will give them the maximum ability to do damage. In other words, full access of the device. So this one is perfect because it has no authentication requires, there's no cookies, there's no authentication parameters, and once you run like 2 commands, you have a full root shell on the device. So in terms of maximizing the impact, if as long as you have a NAS and it has the web interface exposed to the internet, if you have a remote attacker, they can get a root shell on your device without logging in, knowing any kind of secrets, any kind of credentials, and basically run whatever arbitrary command they wish. So that is the culmination of the vulnerability we found and our work to exploit it. And that's about it for my demonstration. Now, do we have any questions? No, doesn't look like we have any questions. All right, I'll see you guys later. Thanks for watching.